Okay, welcome back. What I want to do is to continue with DC transients, charging and discharging of a capacitor. Okay, the instantaneous values of voltage V and current I can be read from a graph. If you plot the graph current against time and voltage against time. Okay. Now, here we are going to use calculations to determine maximum current and maximum voltage in regards to the charging and discharging of a capacitor. Okay? Instantaneous PD, potential difference across C, the capacitor is VC equals V equals open brackets 1 minus e to the minus t over CR. Okay. And please note, this is what we call the instantaneous value here. Okay? This is our instantaneous current. I equals IE minus T over C times R. Okay? C times R. C is multiplied by R. C is the capacitance value times the resistance value, which will change the time respectively. Now, instantaneous charge. Q equals Q, open bracket 1 minus e to the minus t over C times R. Okay? And again, here you will need to practice this because you will not learn this just by thinking that you know it. It will not come like that. Okay? It just does not work like that at all. Okay? Let's change my highlighter back to green. Okay? Now here we have the instantaneous charge. Q equals Q, open brackets 1 minus e to the minus t over C times R. Okay? Now let me just go through that slowly so you can see what we're saying here. Okay? Let me bring this back down, okay, so we can see it in full. Okay, let me pan out. Okay. Now I've used highlighters here because I'm hoping that the highlighter, when I look back at it, gives me a better view and makes the text easier to read. That's what I'm looking for, hopefully. Okay. So let me work my way up. Okay. And as I've said here, Q equals Q. Now you see the common Q equals capital Q, open brackets 1 minus e to the minus t over C times R. Now you will be doing this for yourselves, okay? So it's important that you do the groundwork and some research for yourself so you know what e to the minus t equals in itself, because it's a value that stands on its own, okay? Okay. One more should bring me into a frame. Okay. Okay, what I want to do, look, continue. Now we continue from that in worksheet 1, okay? So let me get my highlighters and see if it will give me highlighter green again, okay? Okay, let's leave it at that first. I mean, it's not working the way I would like it to work, but we can still continue. Now, time constant is equals to T for series RC circuits, okay? The quantity here in the above formula is called the time constant. Now, it determines how quickly VR and VC approach their final value. That is to say, how long it takes them to reach their maximum values, okay? And there we are, okay? Now, consider the point where the instantaneous time t, little t, equals the time constant t, big T. Then from VC equals V, open bracket 1, minus e to the minus c over CR, we have VC equals V, open brackets 1 to the minus e to the minus 1, close brackets. This becomes V, open brackets 1 to the minus 1 over E. This, so we have 1 divided by E. Now if we take 1 divided by E equals V equals 1 minus 0.3679. Now you need to know the value of E, and it's on your calculator. So if you then press the value, now each of you will have a calculator which will function in a different way, but the value of E is constant. It does not change whatever calculator you have. You just have to be sure you've pressed the right button to get the right values, okay? And that's what the value of 1 divided by E should give. Now, I haven't given you the value of E here because E is constant and it should be the same on all calculators, and you need to find that for yourselves, okay? Now, therefore, the voltage equals 0.632 volts. E equals 2.718. Therefore, so if you divide 1 by 2.718, it does equal to 0.3679, okay? Okay, let me just make sure that we can have it all on screen, okay? We can pan back a bit so we get it full. Now, excuse the partly highlighted sections. It just didn't work the way what I thought it should work. So I apologize for that, okay? But you can still see it anyway, okay? And at least you can see that it's my own work, it's my own calculations. You can tell by the atrocious writing. I make no apologies for that at all, none. At least you know it's mine and it's not copyrighted by anybody else. Okay. Excuse me for a second, let me just try and see if I can make sure I'm on the right one. Okay. Page 3. Right. That will be do for now. Okay, I'll come back to page 3 in a moment. Okay.